So hello, good morning, good afternoon, or good evening, depending on where you are assisting us for one more EuroStruct live talk. And today we have with us Genda Shen, which for sure will give us a very interesting presentation about Industry 4.0 and their impact on the management of and maintenance of infrastructures. Also, jointly with me is moderating this talk is Professor Jan Bien from Wrocław University. And I also like to acknowledge our main supporters. So I like to start to acknowledge University of Minho and ISIS as all the platform that we are using today is under their management, boutique company for the design of all the stuff. And also we would like to acknowledge IAPSE and FIB for the dissemination activity of these talks. Concerning some instructions to all of you before starting the talk itself, we are with your micro turned off and the camera as well. And we are also live in streaming in Facebook, in the EuroStruct Facebook live page. And if you want to place any question to Genda, if you are in Facebook, you can put your question there in a message. If you are assisting us in a Zoom, you can put the question on the chat in the Zoom by placing the question directly to the EuroStruct Association. See here with the EuroStruct logo. So if you have any questions during the presentation or during the talk, you just simply send your question to EuroStruct Association, and myself and Jan, we will be able to put this question to Genda. And if you are on Facebook, just simply put the question on your Facebook, on the live. Finally, you are also, and we are also running a survey from EuroStruct where we want to assess the impact of the pandemic and that we are living worldwide on the management and maintenance of critical infrastructures. So if you have the possibility of filling up such survey, it will be great and we will appreciate very much. Now, Jan, it's your turn to present our esteemed guest today and also his speech. Thank you very much.
Thank you. Hello, everybody. So the best greetings from Poland in Central Europe to all participants. And it's a great pleasure for me to have a chance to introduce Dr. Chen. He received his PhD degree from the State University of New York at Butler in 1992. And just after he worked for the Steinman Consulting Engineers in New York City. And after 3 years, he started to work at the Missouri University of Science and Technology up to now. And in this time, he prepared over 400 technical publications, including over 180 journal papers and 3 patents, all activities related to the subject what is will be presented during the presentation today. So generally, his research activities are related to diagnostic and management of infrastructure, especially with application development and application of new advanced tools. He is also a fellow of American Society of Civil Engineers, Structural Engineering Institute, and the International Society of Structural Health Monitoring of intelligent infrastructure. He is also editor in a few journals, like the Journal of Civil Structural Health Monitoring, Bridge Engineering, and Advances in Structural Engineering. So I think more or less is the short research information from the professional position. Dr. Chen is director of Center for Intelligent Infrastructure, as well as University Transportation Center and Mid-America Transportation Center. So you see his involvement in the field presented today is very, very deep, and we will wait for the presentation today. Thank you.
Thank you for your introduction. I would like to take this opportunity to thank the organizer for inviting me for this talk. This is the first time I participated in the live talk like this. So if there is a question in the middle of my presentation, you can send through chat. I'm sure the organizer, Yang, may read, or Jose may read a question later for you. So I will do my best to answer your questions. As you see from the announcement, we are going to share some of our experience and thoughts regarding to future infrastructure management using advanced technologies. So here's a brief outline of my presentation. First of all, I will briefly mention the bridge inspection program, and to the extent possible from a researcher point of view, even though I have a 3 years real consulting experience, that was 20 years ago. So, and then I will focus on future infrastructure management, schematic or framework, or the important components, and then I will mention a few things to benefit or impact the future operation of management with advanced technology. To many of you, probably you know that the National Bridge Inspection Standards in the US was initiated and began in use in 1971 after a tragedy of the bridge collapsing at West Virginia. So that was 1967, but by 2005, you can see from this pie chart, there were over 1,500 bridges collapsed due to various reasons. But one of the top reasons is actually hydraulic, particularly related to scour, and there's a steel corrosion, and there's a collision and a fire and the overstress, of course. In the current bridge inspection manual, I'm talking about 2018 manual, for bridge element inspection, every element, key element has a 4 condition to rate for deterioration. So for example, one of the table I showed below, you can see some detail about defects and 4 states description. It is generally difficult to use a visual inspection to record all defects, and also difficult to accurately estimate quantities without additional tools. So there's, in addition, visual inspection will have some kind of a disadvantage due to accessibility. You can see the image here at the below of during bridge inspection and also maintenance, preventative maintenance. So you have accessibility issue. You also have a safety issue to inspectors. You can see inspector climbing on top of the long span suspension cable. And also sometimes it could cause safety issue to the passenger if you have to stop the traffic from this inspection process. And it's in general, the efficiency is not as high as we would like. But more importantly, on the technical side, visual inspections are quite subjective, and oftentimes leading to inconsistent results. This was a study by Federal Highway Administration. They studied for a single span bridge solid deck, as simple as it can be in the world, basically. You can see the spread of this rating result from 48 inspectors. From rating condition 4 to 6, we are talking about difference in a lot of money, because of 6 in general is okay, you don't need to do serious work, but 4 you definitely need to pay a lot of attention and to do correction. So what we are thinking is future we can integrate the new technology related to the 4th industrial revolution ongoing now. So what we are thinking is we can integrate the non-destructive evaluation, structural health monitoring to the current visual inspection process based on a robotic platform. Because accessibility is a big issue, costing a lot of money to mobilize the equipment from point A to B. And if we have a robotic platform, we can eliminate the accessibility issue. Now, it's a question how to integrate these 3 components, NDE, SHM, and the visual inspection. So I put some description in the middle here. So you can see here, this area in the middle, and different description of critical element for NDE measurement, some representative bridge using monitoring to quantify the degree of deterioration. NDE typically will give you the distribution of problem or distribution of deterioration. Most of the time it's hard to quantify exactly what is the degree of problem. And we do need to visual inspection to confirm before we take action, because the investment on capital investment on infrastructure is huge. So before take action, we still need to expert to make a judgment, final judgment to go ahead to do maintenance, for example. On the other hand, the maintenance side, hopefully there's something beyond the current thinking. We are just exploring whether we can use the unmanned aerial vehicle to support local maintenance, repairing, drilling a hole, or paint, etc. in the future. So you don't have to set a platform for engineer to climb to and to do work. So this is a wonderful picture, the robot we developed here at the Missouri S&T, and I will show you a little bit video later on for the first prototype. Now, the inspection and maintenance approach using this advanced technology are probably further advanced in other infrastructure like pipeline, transmission line than the bridge right now. In pipeline, you probably heard inline inspection with a robot, with all kind of a sensor NDE technique. The robot can go through the pipeline to get inspection efficiently. In transmission industry, also people develop a robot to inspect the cable automatically, basically. And I think one of the reasons their business are advanced so much is because they are line structures. So it's easy to automate the whole process efficiently. More importantly, their operation is based on the revenue they collect. So downside of the operation cause a huge loss of revenue. They can see direct impact of this technology. On the bridge is owned pretty much by the public agency. In the US, the Federal Highway are leading the effort for the guideline and also procedure development. And in the past, Federal Highway in collaboration with Rutgers University already developed a robot called Rabbit for bridge inspection for the deck. So the robot can travel on top of the bridge deck to collect 6 types of data, and then they can try to figure out what is going on with the bridge deck condition through some data analytics. At the Inspire University Transportation Center in Rolla, Missouri here, we are developing a different type of aero vehicle and climbing robot. Because most of the commercial UAV you can do that easily just flying around the bridge to get the overall feeling about the overall condition of a bridge from the surface. It's hard to see beyond the surface. It's also hard to see the condition in the crowded area in the bridge. So if we can develop a new suite of vehicle or robot that can go into the crowded area, that will be very helpful. So we are using actually UAV for magnetic field measurement. You can see on the top image here, and that's for scale monitoring. We also developed a model unmanned vehicle. The idea is that we can combine the flying and the traversing capability, and this wood block represents the girder, for example. So you can here flying to the location and then grab to the girder, and you can traversing from that point, and then you can disengage as needed to move next area. The critical thing to have the traversing mode is to provide a very stable station for measurement. So the result we get from this could be very, very high in quality to give much more accurate assessment. In addition, most of the bridge, for example, a large percentage of bridge in the US are girder type bridge. Indeed, about 60% of deck area in our national bridge inventory are supported on bridge girder. So you can cover 60% girder bridge automatically. So here's a summary of the motivation. We developed so-called BERT, that hybrid system. We can increase operation time because flying consumes a lot more power than traversing. Stable measurement, and then the easy navigation and accurate positioning and reducing all this. But also important, we can use that to dispatch the climbing robot from point A to point B on the bridge. Because if you want to send the climbing robot, you have to follow the bridge member. You cannot pass between two members, even though next to each other, for example, two truss members. But the BERT can serve as a vehicle to move around this different robot. This is for concrete, this is for steel bridge. And recently, last week, actually, my colleague from the University of Nevada, Las Vegas, just finished the exercise using UAV to drill. This simulating a bridge deck. You can see that it's drilling into the bridge deck to do some repairing, UAV. So that's the first demonstration of bridge deck maintenance using the UAV platform. Another critical issue is how do we take advantage of NDE and SHM at the same time? As I mentioned briefly before, NDE is very good to provide the overall picture of a problem area. For example, this is a small reinforced concrete deck. We use a microwave to see the two embedded rebar, and you can see the image is not uniformly show up, and that's because corrosion occurred already. But it's hard to see how much corrosion, how much cross-section has been lost from this image. So if we have the sensor deployed along the rebar that can quantify the level of mass loss occurring over time, and this is basically what we are doing with optical sensor coated with nano particle to simulate the physical corrosion process in rebar. And you can see the wavelength change is well correlated linearly with the mass loss over time. So we can use this correlation curve to tell how much mass actually has been lost based on the physical measurement of the optical, basically electromagnetic wave process, the wavelength change. Now, this data-driven bridge management process has been going on for a while. You heard a lot, I'm sure, but the actual implementation in bridge industry is not wide yet. So there's still a lot of work to do. But I'm going to show some example to you in this framework. For example, if you have this fatigue monitoring, so I have to speed up, I guess. The fatigue management for steel structure, the Japanese professor did excellent job. I think Sakagami, he did a series of study using NDE technology for fatigue management. He proposed this life cycle management framework. And he did using the infrared camera to illustrate how we can get the crack propagation in the conjunction area between bridge deck and the box girder type of supporting girder. So you can see illustrate this is a crack not through yet, and this is a crack through. So you can see the reading, the heat radiation reflection, you have a sudden drop because of a cracking penetration. And he actually attempted to test this technique on the real bridge like this. Of course, he used a manual platform from the industry. In the future, it will be nice to replace that manual platform with a UAV. So it also showed clearly the drop because of a crack crossing the line A. The crack is somewhere here. And he also studied the detectability or the sensitivity fatigue, what minimum size of fatigue crack the technique can pick up. Actually, a pretty small crack, you can pick it up using this technique. So it's a very comprehensive study. So here's another way to show the real study. So if you have time, I will encourage you to read his study papers. The second area I want to show is the power monitoring we have been endeavoring for the past probably 5 to 8 years with US DOT support. SCAL is basically the soil deposit erosion process due to strong current. So it's a scour hole gradually digging into the foundation area and creating a hole, and then the instability of the bridge pier basically. So what we are focusing here is to monitor the critical scour depths, because that's the critical parameter the engineer can use for maintenance. So the strategy we designed so-called small rock, a rock with embedded magnets, and then we can passively get the change of magnetic field when the small rock deploy around the foundation, starting to move around. If we track the position of the small rock through magnetic field measurement, we can know how much a scour has taken place. We actually proved this concept at the Federal Highway Administration Laboratory. You can see that there earlier larger flume in the laboratory using magnetometer to measure the change of the scour hole. Here's the small scale test with one small rock put on top of a small scale pier here. And the final position is here, and here the scour hole is about 18 centimeter deep. And using the magnetic field measurement, we can also conclude it's between 17 and 20 centimeter deep. So it's corresponding to the physical measurement of a scour hole pretty well. And we always successfully demonstrate the scour hole deployed near the pier, it will end up with the bottom of the scour hole, you can see. So, and then we tested in the real bridge. I put the instrument on the UAV. We integrate the GPS and also magnetometer. The first thing we did is with the current of the propeller motor can generate additional magnetic wave interfering the measurement from magnetometer. So we studied how far away the magnetometer must be from the motors on the UAV. So we actually concluded as long as you have about 0.9 meter away, the interference is negligible. So we actually put about 0.92 meter away. So this is a field study at the One Reed Bridge. We can fly through the creek and get the small rock deployed in the water already. The reading of magnetic field is very handy. We can get this task inspection completed in 10 minutes using this technology. And the results are pretty good. You can see using UAV, before we using manual way to do the measurement, the error involved is similar over so many times of the test. You may wonder, well, 0.3 meter is a big number, but remember for scale monitoring, that is actually acceptable as we talk to engineer, because it's very hard to determine the exact depths, and also the change of the depths could be very significant. So if you know that accuracy, we can use that in practice. The other example, quickly go through because of the time, is AI-based inspection video data analytics. That probably you heard more and more AI application in management. And we did actually one project with my colleague in computer science and engineering management, and particularly led by Professor Ching from engineering management. You can see this paper. Is trying to select the critical data image from a long volume of video collected using the UAV. So engineers don't have to sit in front of the computer going every frame of this long video, spending hours tirelessly watch video. So we can use the AI to help select the interesting area. For example, for that process, we need to deal with a number of challenges. For example, the UAV fly, you have a different viewpoint depending how good you control the flight path. So the large, small, you have also different scale. This is a different viewpoint because they're looking up and down or side, all different angle. Sometimes the weather condition is not so ideal, or just underneath the bridge in the middle portion, you don't have enough illumination. All this could create the challenge, and the camera vibration is a big one. And that's one of the main reasons we create the hybrid vehicle called BIRD to eliminate some of this challenge, basically. So this is actually a framework Dr. Ching proposed using a collaborative human AI learning tool through the transferring of knowledge, basically. So in the nutshell, I'm not going to go through the detail here. In the nutshell, basically, we rely on the AI to do the most of work, but to certain difficult cases, we can use expertise from inspector to help improve the training success rate. And so in a way, you inject your expert knowledge into the AI training process so that the AI tool will be more accurate to give you the final results. And this is a specific, the convolutional neural network framework. It involves import the image, basically a video, and then the output is the image. We select, probably only select a few percent of frame from a long video for engineer to review. And so they can spend time to dig into the potential problem area and then come up with a quantifiable, basically, data for engineer to follow up to make decision, for example. And this CNN, we take advantage of the existing CNN from other industry, and we transfer it, because if we start from scratch to train, we need a lot of data. We also take a lot of time and train and tune the network. So if we take advantage, for example, the Microsoft COCO data set, train this ResNet 50 already, we can use that as a base to tune that tool into the bridge inspection with the limited number of training sets. And that process proved working very well and efficiently from our study. And then we have the other region proposal network and region of interest align with the identified potential image, and we have to also zoom into the area of interest, and then finally you have this neural network to figure out the causes of the problem, and also you can mask the problem area. So this is actually another important thing is the human and artificial intelligence. We can go through any number of iteration as needed. So for this example, we tested actually 1, 2, 3 iteration. One of all the unique this center has done is to introduce the temporal correlation to help improve the accuracy of this prediction. What does that mean is, over time, when you have a video sequence, the same component or same interesting area will repeat it again and again, but with a time delay or certain step delta D over distance as well. So we can take advantage of this correlation coherence analysis to enhance the prediction. So this is a summary of the solution process. Basically, it takes about 5 hours for data annotation and also training to finish this network. And the training result without iteration, without human injection, here and with human injection iteration, 1, 2, 3, is all this training data set. The accuracy through this iteration, you can see without, you have about 80% precision. With iteration, improvement is significant, up to 92. So I would say probably 2 iteration will be satisfactory, probably. 90% is pretty good in the training for 10 classes, and including about 2,000 objects involved. With that platform and the framework, our thoughts, we can probably benefit and impact what's the current practice in the future once they are adopted in practice. First, I would think combining flying and climbing robots can provide a very good mobile platform for automated, cost-effective, and safe inspection, as well as the maintenance of bridges. I'm talking about local maintenance. If you need to do large area of repair, there's no sense to do the UAV because you have to, it just takes too long and too much effort to do that. You have to set up platform to do the conventional maintenance. But a lot of time, engineers deal with a very local maintenance work over time. So UAV is very handy. And how to integrate this SHM and NDE in this framework is very important. The integration can improve the capability and accuracy for all this limit state detection. And I believe that collaborative human AI learning can enhance the reliability and robustness of analytics significantly in the future. I just want to say this supported by US DOT through the grant to the Inspire University Transportation Center. I do want to thank all the UTC investigator and the graduate students for their contribution to this presentation. In case you are wondering, this is Inspire Center, all 10 universities distributed in the US map. We are here in the middle of everywhere. And if you have the interest to explore more, these are the websites you can dive into in the future. Okay, thank you very much for your listening, and I'll be happy to answer any question you may have.
Thank you again for this very interesting presentation about technologies for inspecting and preserving infrastructure. So before placing the first question, I will only like to inform about the procedure again. So those that are assisting us on Facebook, you can place the question directly on the Facebook in the message. And for those that are here with us in the Zoom, you can place the question directly to the EuroStruct Association account. And then this question will be sent to me or to Yen, that is moderating the talk with me today. Also, before starting the first question, I would like to inform about the survey that we are running, and you are kindly invited to fill in about the management and maintenance of critical infrastructure during this COVID-19 period that we are living nowadays. So, Ganda, first question that I have to you is concerning US and what advanced technologies were incorporated in the bridge management in US in recent years.
Okay, so that question actually, as I mentioned, I'm now as researching the university. So actually, Federal Highway Administration will have much better idea about that, how wide they are using. But I was involved in a few Federal Highway organized the workshop and discussing the. So I believe certainly is the pretty much mandate process. But some states already use NDE technique to some degree to supplement the probing of local area. Visual inspection identify certain areas that are problematic. They would like to understand more so they can use NDT technology. In terms of structural health monitoring, it's a very small percentage. I was actually PI on one of earlier fully real-time monitoring on Cape Girardeau Bridge over the Mississippi River in the state of Missouri. And we have 84 accelerometer instrumented on that bridge. We also did some actually prediction or check on the design assumption for that bridge, because in our area, the seismic input is quite uncertain. So that's one of the main reasons we instrument that bridge. I mean, we means the US with a different agency. I just participate from a technical point of view. So overall, I think the implementation side is way behind the technology development. And I personally believe there are a couple of reasons. One, bridges are, public asset. The reliability and the public image, if anything happen, is so huge that no one is willing to take a very high risk to operate that. So in engaging new technology, always more cautious. Two is probably in comparison with other infrastructure, bridge is pretty much public asset, and then also it's more complicated than other infrastructure, like, for example, transmission. So we have also the funding versus the capacity issue involved. Third, I also believe on the personal level, the current technology, most of them, including myself, have been working, for example, vibration-based damage detection, for example, in my early career. Now I realize that it's not that easy to draw a conclusion based on the vibration-based signature change unless you see huge damage to a structure. So that means whether we can use these vibration-based technique for some earlier damage development stage is still yet to see, because there are so many other factors, seasonal change and construction environment, environmental change, all this can change the vibration signature. So if we look into more on the other side of technology, NDE and the sensor that can give engineer the critical parameter, The example I use for scale monitoring for maximum depths, that's actually the parameter engineer need to understand the stability of bridge pier or foundation. So if we can provide that critical information, maximum scale depths, to engineer, that will be more interesting to engineer to use the technology instead of you provide a lot of vibration data and trying to figure out how much frequency change due to the foundation scale hole around it. It will be a long mathematical process, and engineer will see that probably is a far stretching or sometimes could be daunting, process for engineer to use the results. I think these are now certainly there's a policy issue also involved, but these are probably the issue we have to, as a researcher, to help contribute and resolve before, practitioner can actually embrace our technology and use them in practice.
Thank you. Now I'm going to ask Yen to place the second question. Yen, please.
Yes, thank you. Genda, you presented a number of very interesting advanced technologies, but it was mainly the presentation from the laboratory. And my feeling is that there's relatively long time between the tests in the laboratory and implementation in the practice. Can you tell us what's the situation in the United States in this, and what are the main reasons? If it is too low level of the funds for research or something else?
Okay, I answered the easy part first. What is the second part? What is the low level of funds for this type of research? I believe if a researcher can bring a technology, inspector see they can use tomorrow, they will give you a fund. So I think the question is whether we can come up with show technology is really helping engineer to do their job. That's I think the critical question. Now, obviously, there is an overall constraint like funding coming whole nation, or for example, during this pandemic period of time, obviously something like our business will not be highlighted. So everybody is focused on the virus and solution and mitigation. So in the first part of the question is the technology side. The infrared camera is only one example I illustrate. There are other NDE techniques. Most of you are familiar. I'm sure there is a GPR, ground penetrating radar, impact echo, eddy current, or ultrasonic. There's many technology. But some technology are more suitable for adoption on UAV, for example. For example, the infrared camera. We're having 2 infrared camera. We put on the UAV, and so we can replicate the basically measurement like you see from the Japanese professor. Instead of a manual platform, we can put on UAV, and then we can fly the UAV grab on the bottom flange of a girder. And then from there on, we can just get the same infrared imaging like I presented in my presentation. So in this process, of course, there are challenges we have to deal with. For example, we have to make the measurement device miniaturized, smaller, so that we can put on the UAV due to limited load, and due to also, if it's too heavy, it's also could be a safety issue around the bridge, for example, if it's very heavy. So there is a challenge to do that. But once we developed this type of technology, for example, infrared camera on a hybrid vehicle, we can provide the similar quality if not better quality image than what you see in my presentation. Because in this case, the infrared camera can put on the UAV in close proximity to the bridge structure members. So the quality you may get is much better. The heat environment, because infrared image is very sensitive to the heat environment around the structure. So the heat environment, when you work in close distance, we can also better control. And therefore, we can have more insight how to interpret the data if we know the heat environment better than in general open area. If you set up the infrared camera on the ground, for example, you will be farther away, and anything between this camera and the bridge could be influence the measurement, for example. So that's another point I want to emphasize. So we are going there, but it's still quite a way to go before you see actual implementation. Our center goal is at the end of 2 more years, we hope we can demonstrate this technology to engineer is feasible, is doable, and promising. That's our goal. Yeah, you have another question? Yeah?
Yeah, if possible, because in this process, from our experience also, very often we can find, let's say, the human factor. So my question is, did you include in the presented problems and proposed solutions in the teaching program at your university, or it is for the postgraduate study?
Yes, as part of our center goal is to parallelly create a training center, training capability for millennial graduates or for seasonal engineer to get used to this new technology. Because as you say, they are not trained for this type. So we actually will, in the process to establish that center I call virtual. I think it's basically, it's through basically the augmented learning and integrating the virtual and the real bridge and video and sensing data into that platform. And we will train an engineer or a student in the laboratory first, and then bring to the open outside the laboratory to test them, and eventually go to the real bridge to test them the skill to use the advanced technology. So we are in the process developing that training tools. In next 2 years, we are supposed to have some preliminary training tools available to demonstrate the advanced technology can be brought into the engineering profession through this training process. As an example, most of military like Navy warrior trainees, they are actually trained through the gaming environment, a simulated environment. And the professor working for part of the development of this training center is actually the one who developed also use some other training tools. So we are actually look forward to establishing this new center, which is very critical, as you pointed out.
Good. I have one question for you from the audience. They mentioned that these technologies improve the capacity to assess the health of existing structures, and they ask you what you think if they will also affect the way we design new bridges in the future.
Okay. Before I forget, I would like to remind you, I will actually deliver a webinar, I think in mid-September. I will send you that date on the skull monitoring topic only. as part of the Inspire UTC webinar series. So I will send the link to Jose, and you can distribute that as needed. Come back to the question. So could you repeat the question again? So
it's about the aspect if these technologies will also affect the way we design bridges in the future.
Yes. I would say to some degree. I give you the real example. I personally get involved. 10 years ago, I was invited by Missouri DOT to investigate why a suspension bridge suddenly collapsed due to fracture of one of the critical steel link at the cold temperature -9 degrees below zero C. So it turns out the reason is in that area, the dirt accumulated over time right below the deck. And that area is closed and the inspector cannot get into it to inspect in detail. So therefore, in the sense, we need to change the design practice for the construction part in the future to keep maintenance in mind. So coming back to this new advanced technology also, because this new technology, if we demonstrate the value we bring to the professional engineer is a very, very critical value added, then if we change the design process slightly to accommodate more use of this technology, it will be more beneficial for this engineering profession as well. I'm not saying we change the design just for placement of technology, but if it makes sense to get the more positive, useful data for future management of infrastructure, why not? It doesn't cost additional money if you integrate that in the design process. It's just one additional factor among many other factors we have to take into account anyway. And another example I want to say relevant to your question is some of this NDE technology. For example, if I use the acoustic emission, for example, and you could actually tune, if you design the structural member such that you can maximize the acoustic emission signal by basically kind of periodic tuning type of technique, for example, you could get a lot more reliable or high fidelity signal. And so that the result coming out of AE device will be more reliable, more consistent. For example, we already designed the perforated structural member already. But if you just, instead of an arbitrary spacing of those holes, if you tune those holes to the working range of the instrument, and that will enhance the capability of maintenance or inspection in the future. These are just a minor example, but again, I'm not chanting to change the design process just based on this, but there is a benefit to do that, to integrate the whole process from design, maintenance, and design, construction, and the management, the whole process into one digital twin system. I was also chanting through the Center of Intelligent Infrastructure. So that's something our group here is also looking into that. Basically, as I say, integrate the whole process of creation, design, planning, creation, and the management of the infrastructure into a gigantic digital twin system. So that's something I think is also important.
Thank you. Yan, please. It's your turn now.
Yeah, I have a question. Some of the people are afraid that the application of new technologies, robots, and so on will diminish the number of jobs for people, not only in civil engineering, but generally. What is your point in the case of civil engineering?
Yeah, that is actually that's the kind of question I heard many times from my presentation. Is it simply because people are not familiar with this new technology, every time we step into a new territory, there is a natural, fear. Basically, this is the same thing, no exception. The way I see it, we actually, if we do it, introduce this technology and then provide a good training, and it's a matter of changing the type of job instead of a losing job. I would say we are actually moving away laborious job to something more interesting job for future engineers. For example, you don't have to climb to the bridge anymore. You need to master the skill of operation of this vehicle, and also understand with some understanding about how the image presentation will look like. You need to see defects through the image and distinguish what type of issue or how much a problem, especially later on if we integrate augmented reality, you will have another layer of complexity for inspection, for example. You need to get the train and the practice in a different area, basically. So this new job should be actually more interesting than the conventional, laborious type of work, actually. So I'm not really thinking it will reduce the number of jobs, but it will change the type of job in infrastructure management if we adopt these technologies.
Okay, thank you.
Genda, one of the points that is also raised here by the audience is with respect the fact that there are some slow acceptance and some limited applications of these technologies in terms of policy, standards and policy making, and also of technology. What is your feeling about that?
I think that is true. I think my observation is true everywhere in the world. So I think we have to take probably two approaches simultaneously. One is the ground-up approach. As a researcher, we need to demonstrate the value-added feature of our technology to practitioners. As I mentioned, we need to provide the data that is directly useful for engineers' practice. That's one aspect from ground up. Now, we also need to work with people like in the federal agency, state agency managing the infrastructure. So this top-down approach is also important. Because you cannot just working down and then top even don't know, and then the process of adopting new policy and procedures takes a long time. So you need to engage them in the process of the technology development, and that's the top-down approach. Our center, Inspire UTC, has industry advisory committee, and that includes the one representative from each state Department of Transportation participating with their university participating in the center. We also have one representative from Federal Highway Administration. So they are supposed to be aware of every development we have at the center from day one. And I'm also actually right now is leading a 5-year proof-on study with 7 state Department of Transportation, and also, many of them outside the Inspire Center. And in that proof-on study, we'll also engage Federal Highway and then seek their input on the development of that initiative and the implementation as well, with the intention that the outcome from this proof-on study will be available to more people through the federal distribution network. And more importantly, we can present it to more professional engineers and then the leadership in federal levels to see the potential initiative to probably changing policy and procedure in the future. and to support the use of new technology. So we have to take a top-down and a bottom-up hybrid kind of approach to address this issue. But as a researcher, I cannot emphasize enough, it is our responsibility to deliver something practical, value-added results. I think that's very important.
Yeah.
Okay, I have a proposal, not the question, I think, maybe the question. I feel that it would be nice to have more close cooperation between the centers in Europe and also EuroStruct, our organization, in this field you presented today. And also I'm personally very interested in the close cooperation because I'm also chair of the training center for bridge inspectors for the whole country in Poland. And the cooperation would be nice because the bridges, they don't know if they are in the United States or in Europe or somewhere, and the facts are similar problems. And I think it would be nice to arrange a kind of cooperation. Would I address my comment to Jose, mainly to Jose, to arrange something in the framework of our organization, I think. What do you think about it?
I fully embrace your thought in that international collaboration is one of the things I also highlight in the original proposal for this center and also the Center for Intelligent Infrastructure. Initially, when, by the way, the Center for Intelligent Infrastructure was established September 1st last year, so it's relatively new. I have folks from London and then folks from Hong Kong and then China to explore the potential collaboration in the future. I'll be very happy to visit your organization and to explore potential collaboration in this direction. And you are also welcome to visit us to see what we have done. We have been pretty transparent. All the projects we funded at the center will have been posted at the UTC website. So you can also see type of project we funded so far. And as I say, if you come to our campus after probably the virus issue got resolved, I'll be happy to show you around our new facility. Our center is building also 4 or 5 laboratory. One is I mentioned already, birds is for field operation. So we will have a vehicle for student and engineer travel around the country to do inspection. 2 is I call it the REAL. This is a robotic engineering and application laboratory. We can design and test the custom required vehicle in that lab. For example, the hybrid vehicle we design and manufacture and test ourselves. The other lab is a virtual, I mentioned already. That's mainly for training, augmented learning laboratory, basically. If you allow me, I could actually, well, I didn't have a note here, so maybe I'm trying to read that virtual, but basically it's based on augmented learning to train professors and also students to use advanced technology. And the other one is SPAR. My earlier lab is focused on the sensor development and calibration. The sensor like Smart Rock I presented is also part of that lab development. And and we also have the office to encourage collaboration. I call it CORE. It's a collaboration office for research and education. So we are embracing collaboration internally and externally. So I like your idea to begin to plan for collaboration with a European country. I will be thrilled to contribute or play some role in that, of course, and I'll be happy to do that.
One question from the audience now. This is respect with the data collected and used to assess the breach condition. What type of data, or more precise, what type of information can we get, and what can be done in order to make this more consistent than it is now? Because most of the data that is collected is based on the condition rating that has a lot of subjectivity, as we all know.
Right. I think the latest version of this AASHTO guideline for bridge element inspection includes many photo, like a reference photo for different conditions. And the US is also thinking, as a matter of fact, TRB will start a new NCHRP project focused on the use of unmanned system to get more consistent data. Exactly what you are talking about. Probably later fall this year. So there is a push to implement more bridge element inspection with advanced technology to provide more quantifiable data. So we can eliminate, most of this subjectivity in the collection of data, basically. So that's part of an initiative I think is going on in the US, and I'm sure elsewhere the same situation. But I think that there's still some way to have the data fusion technology to provide engineer with something convincing data. Because as you say, from different technology, just, for example, GPI in recurring and acoustic and the photo image, the result you get from this different technology, most of the time actually is not that consistent to draw a convincing conclusion. So that's the challenge we have to deal with and find a way to advance from research point of view so that practitioner will not be confused with all these different types of results for the same problem. That's probably one of the most challenging issues in terms of the intellectual work in research community, how to further understand how the data from each measurement technology are derived and can fuse this data in more physics-based, not just in a database, because a lot of data fusion technology developed by, for example, computer scientists, and I have nothing against them, but sometimes they lose the insight of like a practical application side. So it also help to probably tune or develop a new data fusion technology, taking into account the physical happening, even interacting with different measurement instruments, so that we can have much better data fusion results to present engineer with more reliable. One of the projects at our Inspire Center and directed by myself is focused on the probability of detection. For each sensor itself, we actually need to understand what is the probability of detection at the 95% confidence level, for example, because the sensor will give you also variation, and different sensors give you different variation. So that's part of the inconsistency as well from different sensors. But if we all understand the probability of detection on the same consistent basis, like say 95% confidence level, then we have something to compare and to fuse the data. We have much better foundation, reliable data. So that's just one example.
Thank you. I'm only going to put one last question from my side, and then I'm asking Yen to put our final question. So from my side, we have here a last question, which is from the audience, and it's about the application of robots on the maintenance of bridges. They are asking if you know cases of application on bridge pavements and also on bridge secondary elements such as joints or bearings. Do you have any information if there is any kind of application of robots for these maintenance activities?
Yeah, I think so. The okay, so maybe you can repeat the question.
The question is about the application of robots in maintenance activities, and if you know or if you are aware of any application on the maintenance of the bridge pavement, asphalt or two mills or whatever, and also of bridge elements like expansion joint and bearing. Is any kind of robo application on these activities, if you are aware of that?
So yeah, I'm aware quite a few for pavement. There is a group from Michigan Tech University focused on the pavement type of inspection and using UAV. So we have some exchange over time, and there are other group in East Coast also work using UAV, focusing on the pipeline. I also have a project on myself focused on inspection of pipeline as well. In terms of a joint inspection, that I don't know specific study yet, but we are actually looking into that with this hybrid. Because the hybrid, we can travel to the joint area and stop, just like you have a very steady platform or station, and to get very, very fidelity video, or we can even use a light to see the joint area in detail, just like a human. You have one. If we, for example, in the future we have a robotic arm also, you can use one hand to hold the torch light, the other you can just take data. So similarly with this platform, there's many opportunities. We can expand upon that, and joint inspection certainly is one of very interesting topic in my mind, because I was a designer inspector for more than 3 years in New York City before. I actually personally climbing around bridge before in crowded space. So it will be very nice to have a robot going through inside of myself, crawling like in the space only like a 2 or 3 feet space. In certain area underneath the bridge deck, they have a lot of utility like buildings. They take advantage of the space in the urban area. That's the area I was inspecting before and crawling all around. And it's very unpleasant, for example. So yes, joint is one of the most critical elements in bridges, obviously. So we need to pay close attention. But that's the problem area with the off-the-shelf vehicle, because you cannot see details inside the joint area, just flying around the bridge. That's one of the main motivation for me to start this hybrid vehicle actually, because I want to see the detail around joint area. I want to see the detail about the welding connection area. For example, built up girder. If you want to check weld crackings, you cannot see from flying around the bridge, you have to go close in very, very short distance. That's the only way you can get result. And the other thing is, if you flying around, it's difficult to see beyond the surface. Most of the imaging technology are good for surface features, right? But you cannot see what's going on inside. The interior defects probably can be done by GPL or microwave technology, and maybe some other indirect way to infer the interior problem. If we want to implement the GPR, we cannot just put on the flying robot, flying vehicle, and that probably doesn't work well. So we have to put on either climbing robot or the hybrid vehicle. We can do some inspection for interior defects.
Okay. Yeah.
Okay. So my question is, what do you think about the interaction between the diagnostic and the monitoring methods you presented and the technology of BIM, so Building Information Management? As a bridge engineer, so we usually translate bridge engineering, bridge information management. But what do you think?
I would think the NDE mostly is for diagnostic work, is more for prognosis, and then the integration is very important to give overall global distribution and the local probing. Now, in terms of integration into the building information model, that's one of the things actually we are thinking in the digital twin initiative. In order to create a high fidelity digital twin of infrastructure, we got to include the building information model. The key challenge is, how do we integrate the computational model and the building information model? If we just simply add these two together, 1 + 1 = 2, that's probably not going to work very well for that kind of digital twin. If we truly want to develop a useful digital twin, in my humble view, is we have to integrate this modeling technique based on the interest of end user. For example, along the line, we can, as a researcher, we can provide the open source platform to create a digital twin of any infrastructure around an urban area. So basically, you have a basic infrastructure network in the urban area already. But a particular company interested to develop new infrastructure or maintain the existing part of the infrastructure, they can use this open source platform and build on top of that with limited resource to tailor into their specific needs. If their needs is not looking to a lot of detail, then they can focus more on the high level of modeling, the global, maybe not the detail modeling, and maybe not so much detail in building information modeling. But if somebody is interested in the very detailing work, planning for tomorrow, next week's task, then they can look into more detailed information. With the limited resource, they can tap into this open source platform, and they can do that with limited resource and in the limited time. So that's what I was thinking, to integrate this building information. But as I said, a few technological challenges. This could be a real grand challenge to integrate things effectively, because as I mentioned, 1 + 1 = 2 probably doesn't work. So we have to do a lot of thinking out of box thinking to develop a new tool in the future. That's one of the things you said, the infrastructure. is interested to drive in that direction.
Thank you.
Thank you.
Thank you, Jan, for sharing with me this moderation. For sure, again, I agree with you, and we need to combine further some initiative for future collaboration between Europe and US. And once again, many thanks for being with us today. Your experience is very valuable for all. So this is quite interesting and was quite interesting, this discussion. Just before finalizing, I want to give you some brief information. So the IAPSE 2020 Symposium in Wrocław, the early bird registration was extended until 15th of July. The IAPSE 2020 Symposium in Ghent, the call for abstracts is already open. I forgot to mention one of the chairs of Wrocław IAPSE is here with us today, is Jan Bien, so our esteemed colleague. The FIB Symposium will be fully online from 22 to 24 of November. Then I will, with respect to EuroStruct, I would like to give you some informations. We're gonna run a training course on quality control of bridges and structures. It will be online from the 2 to the 4 of September this year, and the registrations are already open. So those of you that are willing to attend the course, or if you want any colleague, you can do the course online and you can register on our website. The conference next year, 2021 in Padua in Italy, from 29 to 31 of August, the launch for abstracts will be released very soon. And to finalize, I would like to invite you all for the next talk on the 16th of July next week at 2 p.m. Central European Summertime with our colleague Alfred Strauss on international activities associated with the safety and lifetime requirements of existing infrastructure systems. So if you have the possibility, you will be more than welcome to attend our next week talk. Once again, thank you very much to all of you, Genda and Jan especially. And
can I add something?
Yes, please go ahead.
Well, I want to thank you and Jan for moderating this talk, and also the EuroStruct organization for this opportunity. I do see potential collaboration in the future, and I'm always open to collaboration. But by the way, actually, my coordinator just sent me my webinar schedule on September 14th. That will be focused on basically bridge scale monitoring in detail. So I will present in 45 minutes basically on that subject. So if you are interested, you can visit our Inspire UTC website and to see and get the registration and then participate in that webinar as well.
I suggest you send me that and we can share among the EuroStruct network.
Right. We'll send the abstract and other information to you, and you can.
For sure, there'll be some students interesting to attend, for sure.
Thank you very much.
So once again, thank you very much.
Thank you, and
nice day.
Have a good evening, you, right?
And keep safe.
Yeah.
Bye-bye.